Hello everyone, welcome to Digital Electronics lecture series. This is lecture number 16 and we'll be seeing the K-map technique. So there are a few reduction techniques. The first we have already studied Boolean algebra. Now we are going to study Karnaugh maps, that is called as K-map, and the third is Cohen-Maklowski method. There are some more methods which require some computations, which is of course done by computers, not by humans. So if the number of, what is this reduction technique? See, if we are given a logic expression, we want to design a circuit, so it may require large number of gates. But if we use Boolean algebra, then the equation, logic equation, it becomes much shorter and we require less number of gates. So Boolean algebra helps in that technique, that the number of gates reduce. When the number of gates reduce, we get a good advantage: less number of gates, less time consumed, less power consumed. Okay, so there are many advantages. The circuit will function similarly. But Boolean algebra is suitable if the number of variables are 3, not more than that. Of course we can solve it even if the number of variables are 4, 5, 6, but it will be too much complex. Okay, so it is suitable up to 2 or 3 variables is okay. So if the number of variables are more, 4, 5, 6, so Boolean algebra becomes too much complex. So it is too much complex to solve using Boolean algebra. So we use the K-map technique. So K-map technique, we draw the truth table in the form of a map and solve it. And this technique is very much efficient and fast as compared to Boolean algebra. Of course, it also uses the laws of Boolean algebra. So this is suitable for 4 to 5 variables. If the variables are more than 5, then again this becomes too much complex. So then we have this Cohen-Maklowski method, which is suitable for more number of variables. Okay, so we'll first study today. Now we'll study this is K-map technique. Now before starting with K-maps, we have to learn some concepts. So we'll brush up some concepts. We will just go through some concepts to understand it properly. Okay. Now the first thing before starting with K-maps is we must know what is the meaning of a max term and mean terms. So max terms, they are denoted by capital M, and mean terms, they are denoted by small m. Now suppose we have a two variable, okay, two variable truth table. This is a two variable truth table, 0 0 0 1 1 0 1 1. Now what are the mean terms in this case? Okay, so first I will write the mean terms. So because this is a is 0, okay, a is 0, so I write a bar with then and sign, okay, dot. And because this b is 0, so b bar, this is b bar, this is the first mean term, so this is mean term. Then here 0, so this is a bar, then and this b is 1, so it becomes b. So wherever 0 is there, we will put bar, and where there is there is 1, we will put uncomplemented form. So this a is 1, so this is a, and then b bar, then finally ab, a dot b. Now how to get the max term? Max term is entirely opposite of mean term. So here we have a bar, so here we will have a. So here this is dot, that is a and, so here we will have this or sign, so dot becomes plus, and this b bar becomes b. Then here we have a plus, that is or b bar, then a bar or b, and finally a bar or b bar. So these are the max terms and mean terms. Okay, so suppose if we use the mean, if you see the mean terms, so the mean terms, they are the products, and max terms, they are the sums. And in few lectures back, we studied the concept of sum of products and product of sum, okay, which is called as SOP. Sum of products, short form is SOP, and we also did this products of sum. So this is POS. So if we take the mean terms is these are the product terms, okay, and max terms, they are the sum terms. So whenever we want to design a circuit, okay, using SOP form. Okay, whenever we want to design a SOP form, we take the mean terms, okay, mean terms for which output is 1, okay, for which output is 1, and this logic for drawing this particular SOP equation, we require the AND OR logic, which is also equal to NAND logic. Okay, so it can be easily shown that a circuit which contains AND OR logic is similar to NAND logic. I will explain this after this one. Okay, what is this, what I am talking about. Then for POS, if we have a POS equation, if we want to construct a circuit using POS equation, we take the max terms for which output is 0. This can be constructed using OR AND logic, which is also equal to NOR logic. This is what we have. Okay, let us take one example. Suppose if we are given a particular gate, we are given a particular equation, then how to we are given a particular truth table, then how to draw that particular gates. Okay, how to convert it into how to realize the gates. Okay, how to realize the SOP equation or POS equation, that we'll see now. Okay, now suppose I am given this particular truth table A, B, okay, and these are the two inputs. So I have 4 combinations: 0 0 0 1 1 0 1 1. So this is a truth table. Okay, this is a particular truth table, and I want this output I am just drawing. Okay, y is suppose 0 1 0 1. I want to design a circuit. I want to design a circuit for this truth table. Now how I got this truth table, this is just an example. Okay, this is just an example. Okay, now now suppose I want to realize, I want to draw this particular I want to realize the circuit for this particular truth table. Suppose now using SOP. Okay, I want to draw using SOP form. Okay, now for SOP form, I will just write all the max and mean terms. Okay, or what are the max terms and what are the mean terms. So I'll just take this max term. What are the max terms for this? So this is the max term. So first the mean terms. Okay, so mean terms are A bar, B bar, A bar, B, A, B bar, and A, B. Okay, now using for SOP, what rule we have, we can see what the rule says. For SOP equation, we take the mean terms for which output is 1, okay, and which can drawn by AND or NAND logic. So here this two inputs, okay, I will just mark it with green. So this combination here, we have output as 1. This is the mean term for which output is 1, and here we have another mean term for which output is 1. Okay, so these two inputs are there. So I will write the equation y is equal to, so I write the SOP equation for this is 1. So what is the mean term? This for this one, what is the mean term? This is the mean term. So this is A bar and B, and this one, for this one we have this. So this is SOP equation, sum of products. Now to realize this SOP equation, I took the output for I took the mean terms for which output is 1. Okay, there are 4 mean terms, but only those should be taken for which output is 1. Now how to realize the circuit? So realize the circuit, I have this AND OR combination. So this is one AND gate, this is another AND gate. So this is AND gate, this is another AND gate, and then so this input is actually this one. For this one, input is A bar. So I take A bar, and this is B, and here for this input is AB, A and B. So this is A, this is B. So this output is A bar and B, and this is A, B. Okay, now we have to sum this. Summation, for summation we require OR gate. So I draw OR gate here. So this goes here and this goes. Therefore we call it as AND OR combination. This is the AND OR, because here we have AND gate and here we have OR. Okay, therefore we call it as AND OR. So here, to realize this SOP, we require AND OR, and we can show that this is also equal to NAND. NAND means what? We replace all these gates AND and OR by NAND. So whatever output we are getting, we'll get the same output, okay, using this NAND gates. So here also two ANDs are replaced by NAND, and this OR is also replaced by NAND. We'll get the same output as AND OR. So let us summarize. This is for SOP. So for SOP, we take the mean terms for which output is 1, okay, and we got this. Now suppose we want to design, suppose the same circuit with a POS form. So for POS, suppose we want to draw for POS, I'll just write it here. POS, what will happen for the same case? POS, okay, I'll just shift it here and use this white one. So for POS, we take the max terms. So what are the max terms? I will write the max terms here. So max terms are A or B, A or B bar, A bar or B, and A bar, B bar. These are the 4 max terms. Now for max terms, we take the output which is 0, okay. So this is 1, this is one output, and this is another output. So for POS, using POS, we take the max terms for which output is 0. So these are the 2 outputs, okay. So this output is A or B, okay, and then we have this A bar or B, these 2, this one and this one, okay. Now this is a POS equation, and for POS equation we require OR AND combination. So OR AND means what? We have OR gate, because first is summation. So this is summation, summing, then again summation. So this is the sum. The first sum is, this is A, this is B. So this one for A, B, and then this one. So here we have A bar, and here we have B, okay, and they should be ANDed because this is the dot here. So this is what we get, okay. So this is how it works, okay. So this is the SOP, and this is actually the POS form. So for POS form, this is what we have. This is OR, and this is AND, okay. So here we can show this OR AND is also equal to NOR, okay. Now let us study how to draw a 2 variable K map, how a 2 variable map appears. So this is a truth table. I am just randomly selecting this truth table, okay. Suppose I have this 0 0 is 0, 0 1 is 1, 1 0 is 1, and 1 1 is 0. Now how to draw the truth table for this particular truth table? So here I first draw a square box, okay. Then I write A bar A, and B bar B. So first of all, how to enter? We have to enter these things. This entries must be done in this particular map, okay. So how to do the entries? First of all, this first input is 0 0. So 0 0 means this is A bar and B bar. So A bar B bar is 0, okay. So this 0, this will come here, okay, this will come here, okay. So first is 0 0, so this is 0. Then second entry, this one 0 1. 0 means A bar, because for A we have 0 and B we have 1. So A bar B, A bar B, A bar B is actually 1. This is 1. So this is A bar B is 1. So A bar and B, they coincide at this point, therefore this is 1. Now next one is this one, A B bar, okay. This is A, and this is what we have is B bar. So A B bar is 1, and here A B bar is this point, this one. So this is 1, sorry, this is 1, and finally A B is 0. So this 0, what we get will come here, this 0 will come here. So this is how we draw a K map. This is a 2 variable K map, okay. So next we have a 3-variable K-map. Now how to draw a 3-variable K-map? So in case of 3-variable, let us first see the SOP K-map. So first we see how to draw a SOP K-map. Okay, SOP. This is an SOP K-map. We will also see a POS. So we have 3 variables. So I write this A bar, B bar. Okay. Then here A bar, B. Here A, B, and finally A, B bar. And third variable is C, so C bar, C. Now see, this sequence must be strictly followed. First A bar, B bar, then A bar, B, then AB, then AB bar. So what the thing is, when we go from this term to this term, only one variable changes. So here we can see B is changing. So A bar remains as it is, B bar becomes B. And when we go from this to this, okay, this to this, what happens? Only A is changing, B remains same. And then when we go from here to here, what happens is only B is changing. And when we revert here the first one, when we come to the first one, A is changing. So when we are going from right to left or left to right, only one variable should change, not more than one variable. So this is the basic idea of K-map. Now let us see how to draw the K-map. Okay, because in this these are the entries, these are the output entries. Sorry, these are the output entries which I have to enter. Okay, for the inputs. So I see there are 4 zeros and 4 ones. So let me trace out where the zeros are. The first 0 is at A, B, C, all 0. So this means A bar, B bar, C bar, for which I should get it as 0. So this 0 should come at A bar, B bar, C bar. So I see A bar, B bar, C bar is here. So this 0 comes here. This 0 comes here. Okay. Then next the other 0. This is 0. So other 0 is at this point where I have 0, 0, 1. It means 0 means A bar, B bar, and C. So this is A bar, B bar, and C. This one is okay. This is A bar, B bar, and C. Okay. So this is again 0. This is 0. Now next 0 is at this point, which is A bar, B, C. So this is A bar, B, C. So A bar, B, C is here. A bar, B, and C is here. So they come to this point. So this is again, this is 0. So 0 will come here. Then finally this is A, B, C bar. A, B, C bar is also 0. So A, B is here, and C bar is here. So they come at this point. So this point is 0. Now because 4 zeros we already traced, so all the others are 1. So we write this 1, 1, and 1. So this is the how we draw a K-map, 3-variable K-map. Now let us see how to, this is SOP. Now what about POS? Now for POS, we do the same thing here. We draw the K-map here. Okay. What changes is, let us see what is changing here. So here we have A bar dot, the dot is not, the dot is there. Okay, so it is understood dot is there. So here we have A or B. Okay, here it was A bar becomes A, dot becomes plus, A B bar becomes B. So here A plus B bar, and here A bar plus B bar, and this is A bar plus B. Okay, or B. So this is what we have here. Now here C and C bar. Okay, because here we had C, it becomes C, C bar becomes C, C becomes C bar, and rest all the things are same. Okay, we see these things, entire these things, they are copied below same way. 0, 0, 1, 0, 0, 1, 1, 1. Now let us see how to draw a 4-variable K-map. So this is the truth table. I have just selected a randomly, these are the 4 inputs, A, B, C, D are the inputs. This Y is the output. This is the output. This output is randomly selected. Okay, how I got this is not, but we just want to learn how to draw the K-map. That's why I have just chosen a random truth table. So this first is a SOP K-map. So in SOP K-map we have to draw this. So first is A bar, B bar, A bar, B, A, B, and A, B bar, and in the column wise we have C bar, D, C bar, D, C, D, and C, D bar in the same sequence as A, B. So there are in this case there are 8 zeros and 8 ones. So let us trace out all the zeros first. So the first zero comes here. A, B, C, D, all are 0 0. It's A bar, B bar, C bar, D bar. It is 0. So this 0 will come here. Next 0 is here. So it's A bar, B bar, C, A bar, B bar, C bar, D. So this is this point is A bar, B bar, C bar, D. Okay, this is A bar, B bar, and C bar, D. This is 0. Okay, this is how we trace out. Then same way, next comes here A bar, B, C bar, D bar. Okay, A bar, B, and C bar, D bar. This is also 0. This is 0. Okay, then next is A bar, B, C bar, D bar is okay. Okay, then this one A bar, B, C, D bar. A bar, B, C, D bar. A bar, B, C. Okay, so A bar, B, C, D bar. Here is 0. A bar, sorry, not this one. A bar, B, C, D bar. This is 0. Okay, and so on. Okay, we can do this. Okay, and we can draw the K-map. I will just do it quickly. You can also verify it. So I have done this quickly. Okay, so these are the zeros. Now whatever left is just 1, so I write this 1 here. Okay, this is 1, or remaining are 1. So this is 1, 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 this is 1. So this is how we draw the K-map. Now this was a SOP. Now for POS, okay, for POS K-map, so this is POS. I will write here. So POS, we have this. So here we have, this is first is A or B. Okay, then see whatever we have here, we take the opposite of that. Okay, so here we have A or B bar, then A bar or B bar, and finally A bar or B. Here we have C or D, C or D bar, C bar or D bar, and C bar or D. Okay, and we copy all the entries, whatever is there, we just copy it here. So we get the same thing. There is no change, just this OR and AND. Rest all things are same. 0 1 1 and 1 0 0, 1 1 0, and finally 0 1 1. Okay, so that's a technique how we today we studied how to draw the K-map. Okay, there is one more technique which is left. How do we represent this truth table into a cell representation, so that we don't need to draw this table again. That will learn in the next lecture. Okay, so thanks for watching.